All right, so remember those cones of depression? Here is a river that's nicely flowing. Here is we'll call it a wetland or a swamp. The water table is up near the Earth's surface. Kind of follows that topography here. That's before. After the humans came, they built a big city. They set some factories out here in this giant field in the suburbs. They started pumping all the water out. The water table got lower and lower and lower and lower. But changed the actual shape of the water table now and sucked the water table so low that it dried up the river and dried up the swamp. These kind of situations are kind of ecological disasters, right? You've changed everything. It's hard to get that back. Another example here, in the before picture, there's a house, and houses have septic tanks, no big deal. The regional groundwater flow is coming from the right, goes down to the left, everything is fine. A farm comes along, puts in an irrigation well, pumps the heck out of that aquifer. Now I have a cone of depression drawing the water down. It's a drawdown, creating a cone of depression. Because of that, then the direction that the groundwater actually flows changes. So now the groundwater flow is carrying the waste from the septic field, the septic tank effluent, down to the home's drinking water well. All bad, bad, bad. And these things happen. Here's another example where there is the ocean. Salty groundwater sits below freshwater. Freshwater floats above the more dense saltwater. We call it like the freshwater lens. That's a normal situation. If you populate the coastline, here's a bunch of houses after, and you put in a well to get municipal drinking water, that's going to lower the water table. So the freshwater water table starts to get lower, and it sucks up the actual salt water. Now you have saltwater intrusion into that drinking water supply, and it's ruined. You can't use that drinking water anymore. When groundwater is depleted and you suck the water out of an aquifer, like we've seen in a couple examples, the pore spaces between the clastic grains can collapse. So on the left, we have looks like a metamorphic rock as the basement. There's some sediment on top of it. The water table is here. Within the water table, here's clastic sediment that has water between the grains, a lot of porosity to it. Let's suck all the water out and go to after. These circles represent pivot irrigation. That's pivot irrigation. Pivot irrigation, they're using up the water, watering these fields. We've lowered the water table now, and the pore spaces between the clastic grains, maybe it's sand, maybe some pebbles, is now gone. We've decreased the holding capacity of that whole aquifer. This leads to ground cracks. So this is real, this crack here in the surface, because we're sinking the ground. That's subsidence. Subsidence because of groundwater depletion. Subsidence because of groundwater depletion has happened in notable cases around the world. The Leaning Tower of Pisa is leaning because it is built on unstable ground that has dewatered, and it is leaning. They pretty much have stabilized it now, but they got to keep it in check. City of Venice, if you've ever been there, you move around the city in a boat. Boat taxis take you everywhere, or the gondola system. And that city is sitting out on marine squishy sediments. And then they extracted the water out to get fresh water, and it collapsed that aquifer. And now the city, they're really having struggles because it floods all the time. The last image is the San Joaquin Valley in California, in Southern California, another place where irrigation has collapsed. The pore spaces in the aquifer and the ground surface is sinking. So at the top of this is 1925. That was literally the elevation of that valley. Here's 1955 and here's 1977. It'd be fun to see. Fun. Nice to see an update of that image. So groundwater, using it, over pumping, over drawing water really causes some negative impacts. The coastline of North Carolina is dealing with some saltwater intrusion right now. Another problem that can come with the use of groundwater is varying degrees of quality. Most groundwater is high quality. It's underneath the Earth's surface, it's going through rocks, it's getting filtered. Clay minerals dissolve off or suck off dissolved ions, it sticks to clays. So it's not even really mineral rich, it's just good pure water. There are some minerals that will get dissolved in the water. One of those is calcium carbonate. It gives water what we call hard water. And that hard water makes the water a little weird. Maybe it doesn't bubble as much. I think I have a slide on that. Yeah, there it is. So we'll talk about it next slide. Dissolved iron, metals like manganese, iron, hydrogen sulfide, gases can get in the water, and also arsenic. Those are naturally occurring pollutants, contaminants, that unwanted substances they get in the water. Okay, so here's the hard water bit. On the left here, it's a carbonate, so we can get calcium or magnesium in the water, and so soap doesn't get so sudsy. It's harder to wash clothes and get them clean. The deposits, kind of like travertine, remember how that came out of a hot spring? You get scaly, slimy deposits on your faucets and your irons, tea kettles, they'll get kind of gunky. The way to clean it up is to have a filter, and the filter would have ions in it that will bind with the ions you don't want in your water. So iron and manganese, those are going to become, because the groundwater just flows through the bedrock and picks up those metals. It can taste bad. Usually it's not bad for you to have those in there. It'll just taste bad, and it might make your mess up your plumbing or maybe stain your laundry, and it won't clean as well. Hydrogen sulfide, kind of like a rotten egg smell. Again, this one may be a little bad for you. Yeah, like if it turns into sulfuric acid and you have an acidic water, but so that one's one maybe you wouldn't want to keep in your drinking water. Okay. Arsenic is very bad. You don't want that in your water. It is a naturally occurring poison, and it's naturally occurring, and it comes from the weathering of the rocks that the groundwater is flowing through. And there's a couple examples here in the text, but you've got to get that tested to make sure you don't have arsenic in your water.